The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, good afternoon, good evening, everybody, wherever you are, different parts of the world. I hope you are safe and happy and doing good in spite of the problems that the world is facing today. To help you, we have an expert in online education, Dr. Yu from Tsinghua University has joined us today. And on the screen, you can see some of the details that you might have already received in the announcement that we've had. Dr. Xinjie Yu is from Tsinghua University in China, and his presentation will be on online teaching, challenge, technique, and opportunity. Really appreciate that he has taken the time to join us. There is a brief description about his background here. Professor Xinjie Yu is in the electrical engineering department at Tsinghua University since 2001. He has a bachelor's degree and a PhD degree, electrical engineering from Tsinghua University. His list of research interests and all the academic accomplishments are very, very impressive, as you can see. So without much delay, I'm going to hand this over to him. I'm going to make him the presenter, and please feel free to text your questions as the time comes, and when we have the question and answers, we will be reading them out. So over to you, Dr. Yu.
Okay.
You can show your screen. Yeah, you can show your screen now. Yeah, there you go. Okay.
Yeah. Good morning, good afternoon, and good evening, everyone. I'm Xinjie Yu from Tsinghua University. With this roughly 1 hour time, I would like to share with you some of our understandings, experiences, and ideologies about this pandemic caused online teaching. I will turn my video off so to save the bandwidth. And okay, I will invite some of you to scan this QR code on the left bottom of my screen. If you have the social media application named as a WeChat, I guess some of you may have. If you have this WeChat application, you can scan this QR code in the screen so that you can interact with me during my talk. You can text some of your feedback or feelings or questions in this application, and your feedback can fly in my screen so that everyone can see it. It will be very interesting to see your text flying from my screen. And let me turn my, today I would like to share with you the teaching and learning, but it's not the ordinary way of teaching and learning. It's almost a purely online way of teaching and learning. I will analyze the challenges we are facing and the techniques we took to solve the problem, to solve the challenge, and the opportunities we will have after this COVID-19 caused pandemic. I'm Professor Xinjie Yu from Tsinghua University, and I'm from Department of Electrical Engineering, and also I'm the head of the online teaching guidance expert group. This group was organized at the beginning of this February to cope with this online teaching and learning environment. So let me take you back into the beginning of this February. So I call it a situation at first. At Tsinghua University, in this spring term, we need to prepare for a large number of courses, students, and the lectures for online teaching because of the disease. We cannot ask our students to come back to the campus. So roughly, there are 4,000 plus courses need to be offered in this spring term. There are roughly 30,000 students who will take part into the courses, and more than 2,000 faculties need to give lectures. But at the beginning of this term, only 400 of whom are familiar with the online teaching tools. So it's a very difficult time for us. So I will show you how we finally solve the problem. That's the first situation. For the second one, we were facing a dispersed distribution of participants. So Tsinghua is right now a international university. So our faculty members and the students are distributed all around the world, which means 24 hours time zones. We need to consider how to deliver the learning material, how to give in lectures for the students all around the world. And the third property at the beginning of this term is that we need to prepare for the long term, which means we do not take the short shot. We need to take a long shot. How long? Which means from the first day of our spring term to the end of this term. So in this day, we announce the online final exams scheme or the program. So which means in this whole spring term, students will not come back to the campus. So at least half a year, or maybe for some students, it's a whole year. Will learn in an online way. So as to my understanding, how to do this long-term dispersed large-scale online teaching and learning, the kernel of it is equivalence. Here, the equivalence means we need to ensure that the online learning quality is equivalent to what we were familiar offline campus teaching and learning. So this is a very high requirement because you must all experience the similar situation in previous several months. We cannot assure students have the proper internet connection, or they may not have the laptop in their hometown. So many of the things will happen, not enough textbook like that. So we say that we want to make sure the equivalent of learning quality to the offline campus teaching. So this is a very high requirement. So how to meet this problem, how to meet this requirement? The equivalence is in the following criteria. We need to make the learning procedure be equivalent to the previous one, which means we will, our students will experience the same procedure, like previewing the material, listening the lecture, reviewing the knowledge, doing homework, Q&A tutorial, taking exam. We need our students to take part in all of these procedures to ensure that they can learn enough knowledge or grasp enough ability. Well, the second criteria means feelings. Our students need to learning feeling and interactive feeling, have the same learning and interactive feeling with previous campus learning. They need to feel that even though it's totally different to learn at home or to learn in the classroom, but they can feel they are same or almost the same. But finally, the most important thing is to make the result, make the impact, make the outcome of our teaching and learning the same or the equivalent to the previous one. So, which means the same knowledge and the skill outcome. How to ensure this equivalence? I think this question should be answered in the following three aspects. The first one is the ideology. How should we consider it? The second one is to consider it with toolkits. What type of toolkits should we select, and how do we utilize the advantages of these toolkits? The third one is pedagogies. Is there any special pedagogy we need to design for this online teaching? So I will explain one by one. First one is ideology, which means how to understand the online learning correctly. So this sentence is written a few minutes before my presentation. I said that to propagate knowledge correctly is not enough, especially in this purely online teaching situation, to ensure learning quality. Because we cannot see students' eyes, we cannot feel the atmosphere, the subtle atmosphere in the classroom. So if we only can teach the knowledge out and ensure that my sound or my screen, my text can be seen, can be heard from the student side, I do not know the quality of learning. So I will be in panic. So how to make me not panic? The essence of a proper answer is, as a faculty member of electrical engineering, I'm quite familiar with closed loop control idea. So the essence of this proper answer is to sample the feedback, sample the students' learning feedback. So if the students' learning outcome is exactly or roughly the same as I expected, I will teach in the same way. But if it's different, for example, students may not understand the previous terms I defined, I cannot going forward. I just need to go back to explain in more detail. But if the students can answer my quiz, answer my questions very easily or with very high correction rate, I can skip a little bit and going forward to another topic. So to sample the learning outcome, and according to the outcome, to adjust the way of teaching is the essence of understanding the learning correctly. So I define this online teaching and learning as a massive means a large number of students, large number of course, large number of faculty members, and real-time interactive. So this is we sample the feedback, we do the adjustment, all depends on the real-time interaction. This must be solved. This must be carried out in a synchronous way, synchronous teaching and learning procedure. So the same way as in a real-time situation, we do the interaction, we sample the students' learning outcome data, we understand the learning quality, and if possible, we need to do the adjustment. So this is a closed loop control idea, which is quite different from what we were familiar, the massive open online course, abridged as a MOOC. So in a MOOC, I'm the author or I'm the teacher of a MOOC named exactly the same name, Principles of Electric Circuits, which has been initiated in 2013, 7 years ago. In this MOOC, I put it on edX and also on ShareTimeX. edX was organized or operated by Harvard and MIT. ShareTimeX is initiated by Tsinghua University, one in the United States and one in China. In this two platform, my course, my MOOC, has attracted more than 300,000 students around the world, which is a very large number of students in the engineering course. So I have a lot of experience in this. In the MOOC, it's a typical asynchronous way of teaching and learning. I prepare the material in advance, put it in the platform, and invite my students to learn in their convenient time. So this is a asynchronous way of teaching and learning. But for this online way. Right now, we were facing our real students, the campus students. We need to do it in a synchronous way, or the semi-synchronous way. So how can we getting things done? At Tsinghua University, as I have mentioned, at the beginning of this term, only 400 out of the 2,000 plus faculty members are familiar with online teaching pedagogy. So we carried out 5 trainings and 1,800 plus lecturers participate into these trainings, and also 600 teaching assistants take part into the trainings. And we recommend 3 types of tools. One is what I mentioned, the RainClassroom, which is a tool embedded in PowerPoint to provide real-time feedback during lecturing, and it can replay the screen recording after it at any time for the students and also for the faculty members. And the second type of tools is a network conference, such as Tencent. We use Tencent conference a lot because it's in China. It's very easy to use, and we also use Zoom. And the third one is a MOOC platform, such as XinjieX, I mentioned previously. The third thing we have done is that we provide a FAQ, including 30 plus questions for online teaching. This FAQ is targeted at the teachers. And we also prepared another FAQ for students, roughly 100 questions. And there are 15 faculty members in this group. What I mentioned is the online teaching guidance group at Tsinghua University. These 15 group members coming from 11 departments. They will teach 22 online courses. So we prepare 22 online pedagogical schemes at the beginning of this term for the references of our teachers. And also we provide 15, every one of our group members prepare a checklist and the contingency plans for themselves and also provided for others to reference. For example, I need to consider precisely what should I do if during my lecturing, during my course time, my internet connection is shut down, or even what should I do during my lecture time, my electric power is blackout. So I need to figure out how to deal with it. And also, as I have mentioned before, interaction is quite critical for the learning quality of this type of online teaching. We prepared roughly 15 clips, video clips for interactive skills to distribute it for everyone of our faculty members. That's things we have done for this group. Statistics. For example, in the 9th academic week of the spring term of 2020, 4,000 plus courses were taught in the cyberspace, purely online. The scheduled course number in this term is a little bit larger than this course number, which means maybe some dozens of courses has been postponed to the fall term. The average attendance rate is roughly 95%, so which is higher than our previous one, than our ordinary way of teaching. I can see that I can attribute the tools we used into 3 stages. The first one is what I give the attributes as information delivery. So which means with the help of these tools, we can deliver the message from teachers to students correctly and synchronously. As right now, we organize a webinar. What I've said, you can hear immediately. What I've shown in my screen, you can see it immediately, or even you can record it, you can see it later. So this tool, I attributed it or I categorize it into the category of information delivery. So you can imagine this organize or compensate or constitute a virtual classroom. So I teach in this classroom, students learn in this virtual classroom. This is the first type. This is only the very soft rapt level. For the second one, we need to know the learning feedback, as I have said before, to sample the feedback. This is to emphasize the interaction. This type of tool can provide the learning effects of students to teachers in a real-time way. You will experience how can I connect the feedbacks. For the third one, at some situation, at some circumstances, we can do the knowledge rediscovery. So this is a very tricky term. As I've said, I taught a course named The Principles of Electric Circuits. So basically, in this course, all the terms, all the analytical methods have been done or have been found in previous 100 years or 60 years ago. So how can we rediscover the knowledge? So we use some of the interactive tools. We organize the innovative environment. We invite our students to consider what you will do if you were facing the problem while the previous engineers or previous scientists were facing the same problem. Maybe our students can have the same answer to their pioneers, or maybe even they can have the better answer. So in this way, we can attract attractions for our students. So we redefine the existing knowledge in an online way. I will show you as the example. I will explain this 3 stages one by one. For the first stage, information delivery, we have plenty of information delivery tools, such as live streaming platforms. In China, we often use such as Bilibili is one name, and there are many of the other applications in the cell phone. I know in United States or Western countries, YouTube Live, UChat, Twitch.tv is the similar live streaming platforms. For the second one, network conference tools such as Zoom or WebEx can be used as the information delivery tools. And for the third one, the RainClassroom I used is a main information delivery tool. This is the first stage. For the deeper stage, there are not so many learning feedback tools. So to experience why should we need to collect the learning feedback, or if we can connect the learning feedback, what can we do? What can we summarize? How can we get the understanding of our students' learning quality? You can scan this QR code. In this time, you do not need to have a WeChat. You can just use any of the QR code scanner, such as a QR code scanner in your social media app, or the QR code scanner in your web browser, any of it. Just scan it. It will direct you to a familiar website named as SurveyMonkey. I organized a quiz for the what is let me see. The question is what is National Nurse Day? It happened recently. What is the National Nurse Day? For example, this is a quiz I need to take in my lecture. So how can I understand maybe the hundreds of my students, how their feeling is? Can they understand my previous talk correctly, I invite my students to scan this QR code and to give the feedback. So you can scan it, and it will direct you to the SurveyMonkey website, and you can give the feedback. Let me check. In my second screen, I can check your live feedback. Okay, I can see that. How many of you? Let's see. Let's move it to this left screen. Immediately, you can see that. Immediately, I can see how my students give the feedback, how many percentage of them can truly understand what I've taught, how many of them cannot. So I can see the number 38 of my students give the feedback, and 27 of them have the correct answer. 3 thinks the first day, 5 thinks the sixth day, and 3 thinks the 30th day. So this is a very easy way. It's very easy to assign a questionnaire in SurveyMonkey, or it's more even. It's evener in the RainClassroom platform. So with this small trick, you can understand the learning feedback. The learning feedback includes sound feedback. You can invite students to speak, to express their feelings. Many of the network conference tools can provide this type of function. And you can also get the text feedback. Live streaming platforms, network conference tools, or the RainClassroom can have the text feedback, such as the screen tweets, or the barrage I mentioned in the RainClassroom. It can also get the data feedback. For example, in the RainClassroom or the Learning Management System, LMS, such as the Blackboard, eCampus, or Canvas, it can give you how many of the students have participated in the quizzes you organize in your classroom, and what's the correction rate, what's the participation rate. And also you can organize this SurveyMonkey type of QR code quiz. This is an example. This is my 2020 course in lecture 10. This is a quiz data. I'm sorry for the Chinese character, because I basically use the Chinese language in my teaching. But if you use your English language in your teaching, you can select the English environment in the WeChat or in this type of RainClassroom. It all can provide the English version. And this is a multiple choice, 6 multiple choice in my one lecture, 19 minutes, one lecture. This is a correct rate, high correct rate, but very low correct rate. And this is a participation rate. So you can understand a lot from this data, which means in my class, roughly 137 students should sit into my cyberspace classroom. For all of these 6 quizzes, more than 90% of them participate in. And previous 5 quizzes, they can easily get the correct answer, but for the final one, only 1/3 of them can have the correct answer. So I can understand the learning outcome or learning quality of my students easily. So I can call it a progressive assessment, which means the assessment can be carried out little by little during the procedure of teaching and learning. But for the 3rd stage, we only have a shortage of knowledge rediscovery tools. To experience this feeling, I also invite you to scan this QR code. This is another questionnaire. This questionnaire is just a multiple choice. It has no correct answer, just to invite you to give the feedback of which online teaching tools have you been used in the past. Let me show you right now the answer. Refresh. We can see that the most often used tools are Zoom, RainClassroom, eCampus, Blackboard, live streaming platform. And with time going by, and many of the students, many of the participants can give their feedback. During this questionnaire or feedback procedure, the students will have high attention for this purely online teaching and learning environment. So maybe 20 seconds ago, the participation is 23, right now it's 31. With time going, more and more students will participate, and it can demonstrate the distribution of our students' understanding for this context. But this is not the knowledge rediscovery. This is just a collection of the feedback. So how to understand the knowledge rediscovery? I will give you an example. In the RainClassroom, we have a function of word cloud. What is a word cloud? This is the PPT slides I use in my electrical engineering or the principles of electric circuit course. This is a graph. This is a nonlinear resistance context. This is a nonlinear UI property of one resistor. We use a piecewise linear model to describe it. For this line, we can use this circuit to represent. For this line, we can use another circuit to represent. But the problem is, how can we know that for this resistor, nonlinear resistor, how can we know that whether this resistor is operated in this region or operated in this region? How can we know that? In previous offsite or the campus teaching, I will tell them we use a way of the trial and error. We don't know which model to use. We just use one model and to examine the condition. If the condition is satisfied, we guess what we have guessed is correct. If the condition cannot be satisfied, we guess in another way. But how can our students to rediscover this trial and error method? I open the screen tweet. I open the barrage to invite my students to give the text feedback. As I have mentioned before, their text feedbacks can fly in my screen. And after a while, I can generate this type of the RainClassroom, the word cloud. I'm sorry for the Chinese character, but this largest one means suppose, try. This means wrong, means error. So this is not what I taught in the classroom. This is what my students said in the classroom. They said we can suppose one situation and to test whether it's right or wrong, they said we can use the trial and error. So we can do the knowledge rediscovery in an online way. And other knowledge rediscovery tools can be generated in the Zoom environment. We invite our students to do the graffiti in my screen. Right now, you cannot draw any line in my screen, but in the Zoom, they can draw whatever they want. So they can participate. They can say they don't understand. They can say, please emphasize this a lot by their drawing. And also, I can group the discussion in the Zoom. So we often use the Zoom. And for the pedagogies of online teaching, it's content fragmentation. I will explain it later. And more interaction and less contents in the class. I will explain one by one. For the first one, content fragmentation, I need to prepare it to the previous one. For the offline campus teaching, generally at Tsinghua University, a 45-minute lecture is connected with a 5 minutes break, maybe another 45 minutes lecture after it, and maybe another 5 minutes break. That's the ordinary way of teaching. So 2 45 minutes lectures constitute a session. That's the general way. Maybe in some special way, 3 45 minutes general session. That's also possible, but the main is 2. But in this online teaching way, 45 minutes is too long. So I recommend a shorter break for every shorter time, shorter lecture time, roughly 20, maybe 25, maybe 15 minutes is appropriate. So 4 to 5 20-minute lectures constitute a session. So the session time is almost the same, but it constitutes more lecture sessions, more lecture segments. That means content fragmentation. And more interaction for the offline campus teaching in a 90-minute session. Generally, I will assign 6 quizzes plus 1 screen quiz. But for this online teaching, in the same teaching time, I will assign more, 1 or 2 more quizzes or 1 more screen quiz. For the third pedagogy, less contents in the class, I will analyze the offline campus teaching, the teaching path of my offline campus teaching. I need to start to provide the introduction. I need to teach them the knowledge point 1. After 1, knowledge point 2, and maybe after 2, I will teach the application of knowledge point 2, and I will come back to the point 3, and after point 3, I tell them the application of 3 and to teach the point 4 and to do the conclusion and to make the extension. That's the ordinary way of offline campus teaching. But if we do need more interaction, we need more break, we have less time for this lecturing. So I need to analyze what is the most important thing I need to make them to understand, and I figure the point 1, 2, 3, 4, and the conclusion is the most important one. So I can delete introduction part, I can delete application part, and extension part, and ask my students to learn these materials, to learn this corresponding MOOC videos after the class. So this can be deleted, and the procedure of the main learning can be enhanced with the help of the RainClassroom, with the help of more intensified interactions. And after several months, all of us can see that there are many advantages of online teaching. The clear with live screen sharing, the clear in the screen way or in the sound way. And also high interaction with classroom functions. Students will not shy because they are anonymous. They do not need to stand at the front of another 166 students. And also, they have the peer inspiration. They can see others' anonymous feedbacks. They can appreciate it, how amazing these students can be. They can do the peer inspiration. And we can also provide a large-scale interactive tutorial with a Zoom screen graffiti I've already mentioned. But still, we were facing some of the problems. One is how to obtain higher engagement level. We want higher to ensure the higher quality. And how to organize the final exams. And to the last but not least, what can we learn from this COVID-19 pandemic caused online teaching and learning, and use these experiences in the following on-site or blended campus teaching situations? Which means, what is the properties of the new normal education teaching, and how can we get ready for it, new normal? So that's all I would like to share with you for this morning, afternoon, and evening. Thank you for your attendance, and I'm waiting to discuss with you.
Wow, this is really fascinating, amazing, fantastic. Excellent job, Dr. Yu. You've given us so much insight into how to move forward in this direction. And thank you for you and your team at Tsinghua University for being leaders in this this effort. I have a few people that I have pulled into the panelist box to give some comments and discussion. So let us see. I've got my friend Paul Gilbert. Would you like to chat a little bit, Paul? I've got Paul and Tan here, and I've got JP Mosen and Hans Hoyer. Maybe have a little discussion with some of you all. Paul, you want to jump in? Are you there, Paul?
Yes, I am. Can you hear me? Can you hear me well?
Yeah, sure. Paul, come in.
Thank you very much, Dr. Yu. That was fascinating. Just for everyone's knowledge, my company, we're in the business of working with universities to provide the teaching equipment, and it's fascinating to hear how you approach the students, and getting the feedback from the students is the single most fascinating piece for me, because I know talking to audiences of large numbers, you don't get that feedback. It's very hard. One particular area which I noticed was the flow of concepts and application. And as a business person, I focus on the application, assuming the concepts are understood and how relevant they are to dealing with certain applications. You deleted those from the kind of critical path in the teaching. I'm just wondering whether the students did actually go and learn about the applications of those concepts.
Yes, they do. I want to repeat my understanding for your question here. Did you ask me how can I introduce the application in my course?
Yes, because you said that for clear teaching on online, you had to be more efficient, and so you cut out some of those things you may have done in offline campus teaching. And so my question is, I think application is very important in understanding how to use a concept, and of course you need to teach all the concepts. But you're saying you delete that and ask the students to go home and do that work. How did you find them, or how do you check to confirm that they are actually doing that kind of thing?
Yeah,
that's
it's a very good question. A very interesting thing is that we emphasize on the application of electric circuit, the terminology, the analyze methods. We very emphasize the application of them, but we delete some of our applications. We do not teach them in the class, but we assign our students to learn them in their off class time. But how to ensure they really watch this video, really watch this video clip? We assign the quiz in their off class. In the classroom environment, we assign the quiz and ask our students to finish the quiz. And also in the last class, at the beginning of my lecture, I will assign 1 or 2 quizzes. The contents of the quizzes will directly be pointed to this application of 2 or application of 3. So in this way, I ask my students to watch the video, and I examine and I check whether they have already watched it or not in the next class.
So do you find that now, I mean, you've got a number of years of teaching experience. So the students that went through this process this year, did their understanding of applications go up, or was it the same? How do you think it worked?
Similar, not the same. I need to be frank that I taught in the class, I teach in the classroom, is the quality may be higher than this way. But right now in the pure online teaching way, the most critical problem is we do not have enough time for the one classroom. We only have 90 minutes, so we need to give up something. In this way, I give up the time of teaching the application to save the time for the interaction, to ensure that students can understand the concepts, can understand the way of analyzing correctly. So this is a trade-off.
Okay, thanks, Paul.
Thank you very much. Yeah.
We can give Tan. You want to make a comment or question? We'll go then Vijay Kanabar from BU after that. Tan, are you in a position to talk? Okay, Vijay, jump in.
Hi.
Comments?
Yes, a really good presentation. Excellent. I'd like to focus. I like your focus on discussions and less lectures. Can we classify then your teaching style as flipped classroom, especially considering you have this experience with edX? So what % of the students are well prepared for your class so that you can dedicate more class time to discussions like you described? Thank you.
Oh, okay. As to the flipped classroom, I have my personal understanding. And flipped classroom means I assign some of the learning material, some of the learning task for my students to finish before they attend the class. And my students and I to do some of the review, to do some of the extended learning in the classroom. So I define this flip. So my way of teaching right now can be categorized as one way of flipped classroom, but this is a light way. Because we have another type of online teaching. We ask our students to learn all the MOOC videos before they attend this online teaching and learning. They have all the knowledge or basic skills before they attend the online teaching class. And in this online teaching class, all they need to do is to discuss their understanding for the knowledge point, to discuss their understanding for the problem solving skills, to discuss their understanding for the comprehensive design problems. So this is what we call the pure flipped classroom. That's another way of teaching. For this way of teaching, only a small number of students in my course, another class, which means 24 students per faculty members. So only for this small number of students, we can organize more higher than my class, highly interactive discussion in the classroom in 90 minutes. So in my one, which means 137 or 33 students in the class, I cannot ask my students to discuss in group, to discuss in person. So basically, this 90 minutes session, roughly 70 minutes. In the 70 minutes, I need to teach. And in other 20 minutes was maybe constituted by 7 quizzes, 1 screen tweets in between this 70 minutes. So this is a slight way of flipped classroom. Students need to preview some of the material, not all of them, some of the material of the MOOC. They can get some not so deep understanding for what I will taught in the class to attend it.
Thank you. Let's move on. Veena, do you have any quick comments? Veena Kumar from India. Anything you want to add? Okay, I'm going to move on to.
I would.
Yeah.
I have a question. I have a question, Krishna.
Yeah, go ahead.
I have a quick question. Dr. Yu, wonderful presentation. So learning. My question is, how do you identify the low performing students, and what special strategies, if any, you use to kind of support them?
Okay, thank you for your question. I will demonstrate this. For example, the toolkits, the RainClassroom toolkits can give me the feedback. This is only the statistics. If I click into this quiz 6, I can see which students can have the right answer, which have the wrong answer. So technically, if I would like to know which students is need to be to take more concern, I can find out their name. But for this 130 students, I do not have time to find out one by one. So right now, I asked 2 of my PhD students to do the data mining, what I call the educational data mining, because we have a lot of real educational data. For example, in this lecture, I have many of the data. The students, the students correction rate, participation rate, screen tweet, all of these data, we can use some of the artificial intelligence algorithm to analyze it and to find out which one might be the one we need to take care of, and automatically assign the supplementary learning material to them to enhance their basics. So we have right now doing this kind of research. I think by the end of this term, the automatic artificial intelligence recommendation function will be added to the RainClassroom.
Okay, great. Tan, are you?
I have one question from Mani speaking from India. Yeah. I have one question to the speaker.
Yeah, please.
Go ahead, please. Make it quick. Yeah.
Yeah. It's a wonderful, very well articulated professor with respect to this online teaching learning. I have only one question. How you are going to measure the skill outcome? Because end of the day, we need the so-called knowledge and skills, and also the ability to showcase your knowledge and skills in the right platform for the students. In what way you are going to get the skill outcomes through your online teaching learning?
Sorry, I cannot understand correctly. Please, Krishna, please.
Yeah, I mean, yeah, the skills. I guess there's knowledge, skills, and attributes. I guess how do you measure the outcomes of the skills? Maybe that's for a broader discussion. But we're going to move on to Tan. Can you speak? You said you can.
Yeah, it's hard. It's hard to assess or to measure the outcome of the skill training, especially for this purely online way. Mm-hmm. In the campus teaching way, we can ask our students to come into the lab. We assign the hands-on learning projects for them to finish so that we can examine their skills. How can they apply the knowledge they learn in the theory class into the application? But for this online way, it's hard. But we do something, because electrical circuits can be simulated in software, such as a multi-sim. It's a software we used, provided by National Instruments Company. So I assign 3 simulation, not only the verified type of simulation, but with some kind of a design type of simulation tasks for my students to finish. So in this way, I can understand a little, not fully understand. I can understand a little my students' skill outcome. That's my answer.
Thank you, Dr. Yu. Tan, are you able to speak? You said you're on the mobile, but I'm still not able to see you on the mobile. So I've kept your mic open, but we have lots and lots of questions from the audience coming in, and unfortunately, we'll not be able to address all of them. But there are some common themes that I'm seeing, Dr. Yu. Okay. Questions about how to conduct examinations and how to have students work on projects and laboratory work. Well, how are you proceeding? I know that that's part of a larger series of webinars that we should be having on those topics. But briefly, can you address the problem that we face about in engineering, about laboratories and projects and examinations?
For the laboratory, some of our colleagues have made progress. They can post the lightweight laboratory toolkits to the students' home and assign the projects for them to finish. Students can take photos, can take the photos and send it to the faculty members' cell phone or laptop to examine. That's one way. And another way, in China, the China's Ministry of Education assigned some of the online interactive way of a laboratory. The real experiment was on the campus, but the student can do the real experiment with only with pure online. So which means there are some of the relays in the laboratory to take this switch on or take this switch off with a command of the students. So that's not all the experiments. Only some of them can be carried out in this way. So that's for the lab. Mm-hmm. But most the labs lab assignment will be postponed to the summer or to the fall term. But for the final exam, which depends on the faculty members' decision or consideration, some of them will postpone it to at the beginning of the fall term. We allow our students or teachers to organize the final exam at the beginning of the September. That's one way. Another way is to organize the online final exam. For me, the principles of electric circuit course will take this way. And another way is to shift the right or wrong, the multiple choice, or the drawing assignment in the final exam previous way into the more comprehensive way, just assign an article or research paper for students to fulfill in 1 week or 2 weeks. So this is a different way of examining. Thank you.
Good. Hans, I'm going to give Hans a chance to wind up the webinar. Hans, come in.
Professor Yu, on behalf of our IFEES and GEDC and also IUC global community, I really want to thank you for a very thoughtful presentation. And as Krishna just said, I think there's several topics and questions that were raised that would require, additional webinars moving forward. One of the questions that I have, and we don't have the time, is how do other disciplines at Tsinghua, for example, learn from what you're doing in terms of this online reality that we currently live in, per se. But I'm not expecting we have the time now, but I do want to say this in terms of for the members of our global community who are present here, is that we've enjoyed the partnership and close friendship, Professor Yu, with Tsinghua University for a long time. Dean Jianbin Liu is a member of the GDC. We are part of the International Center for Engineering Education and UNESCO at Tsinghua. And also we are about to celebrate our 10th anniversary of the partnership IFEES with the workshops that IFEES and Tsinghua University have been offering for almost a decade, per se. I just want you to know, it just confirms the seriousness of our partnership. We value your contribution, and we look forward to continue to engaging with you. Thank you very, very much, Professor Yu.
Thank you all. I really appreciate that we had much more than 500 people. Many people trying to join, could not join. I apologize for that. This is obviously being recorded, and the recording will be available for later on. So once again, thank you, Dr. Yu, for a fascinating, very enlightening presentation. And good luck to everybody. Be happy, be safe, and see you at the next webinar. Take care, everybody.
Okay. Thank you, Krishna.